4.1, we're going to talk about exponential functions and their graphs. So an exponential function has a base a, and x is the exponent. So our function looks like this. It'll be some numbers, some base, bless you, to the power of x, where that base is not 1. Because if we had 1 to whatever exponent, it'll always be 1. So it'll just be some number other than 1. So on this page, it talks about just the different bases. So we could have a base of 2, 3, 10. Base is the big number that has the exponent. In example 1, this is where we need our calculator. So it says evaluate the following. So here our base is 3. So we have 3, and the number in the parentheses is what we plug into the x. 3 to the power of 5. So make sure you know how to use your calculator. In my calculator, I put 3, there's a little caret button, that up arrow, and then 5, and then equals. So 3 to the power of 5 would be 243.
I'm going to love this quiz.
If you're using your phone calculator for now, you cannot use your phone on a quiz or test. But if you're using it to help you for today, you'd click 3. There's a x raised to the power of y button, and then 5, and then you'd hit equals. So if you're using the phone calculator or the iPad calculator for today, this would be how you put it in. But every calculator is different, so just make sure you know how to use your calculator. Let's look at B. So here we have 3 to the power of negative 2 over 3. When I put this in the calculator, anytime you have fractions or any math going on, whether it's the base or the exponent, make sure you put it in parentheses. Sometimes your calculator likes to apply it only to the top or only to the bottom, so just make sure you put it in parentheses. It's a couple extra steps, but it'll ensure that you get the right answer. So I'd say 3 to the power of negative 2. My calculator doesn't have a fraction button, so I would click divided by 3. Some calculators do have a fraction, but this would be 0.4807. On WebAssign, it wants you to round to 3 decimal places, so we would round up, so it'd be 0.481. So you always look at the 4th decimal place to tell you what to round the 3rd one to. Next, we're plugging in pi, so we have 3 to the power of pi. You want to use the pi button in your calculator. Don't just use 3.14 because it'll not give you the most accurate answer. So 3 to the power of pi would be 31.544. And then lastly, we have 3 to the power of square root 2. I'm going to put this in the calculator in parentheses just to make sure that my calculator is doing the math right. So 3 to the power of square root 2. This would be 4.7288. So we look at the 4th digits, tell us what we round the 3rd one to. So it would round up to 4.729. Next, we're going to be graphing our exponential functions. So exponential functions will be one of 2 shapes. It'll either be increasing, like this, or it'll be decreasing, like this. We'll talk about how we can tell if it's going to be an increasing or decreasing graph. We actually have a name for it, which the first one would be growth, and the second one is decay. So when it's increasing, you have exponential growth, and when it's decreasing, you have exponential decay, which we'll talk about this on another slide in a couple of slides. So in example 2, we're going to draw the graph of each function. So when we graph it, we want to plug in values into our x, find the points, and then just plot the points. So I'm going to make a table. I want to plug in values for x. I'm going to get values for y. Bless you. And then plot those points on my graph. Okay, so always we want to plug in some negative numbers and some positive numbers into x. I think WebAssign will tell you what values to plug in, but let's plug in -1, -2, -1, 0, 1, and 2. So our first function is 3 to the power of x. So I'm going to plug in -2 into my exponent. So I have 3 to the power of -2. When we put 3 to the power of -2 in our calculator, we get 0.111 repeating. So I'm going to go to the left to -2 and up 0.111. So that's just barely off of the x-axis, just barely off of 0. Next, let's plug in -1. In our calculator, we're going to do 3 to the power of -1. So that would be 0.333 repeating. So I'm going to go to the left to -1 and up 1/3. So it's barely off of the x-axis again. Just a little bit higher up. Then we have 3 to the power of 0. What's 3 to the power of 0? 1. If you're not sure, just plug it in your calculator. 3 to the power of 0 is 1, so I stay at 0 and go up 1. Then I have 3 to the power of 1, which is 3. So I go to the right 1 and up 3. And then I have 2, so 3 to the power of 2 would be 9. So I go to the right 2 and up 9. Once I have my points, I just connect the dots. So this would be an example of exponential growth because we're increasing here. All right, let's do the second one. So we're going to do the same thing. I'm going to make a table and draw my graph. So we're going to plug in the same numbers, -2, -1, 0, 1, and 2. Now we're plugging it into 1/3 to the power of x. So we have 1/3 to the power of -2. When we put that in our calculator, I'd want to make sure that 1/3 is in parentheses. What is 1/3 to the power of -2? Anybody doing it in the calculator? What do we get? 9. Awesome. So we go to the left to -2 and up 9. Now we have 1/3 to the power of -1. What is 1/3 to the power of -1? What is it? 3. Awesome. So you go to the left 1 and up 3. What about 1/3 to the power of 0? 0. No. 1. So we stay at 0 and go up 1. Again, if you're not sure, just plug it in the calculator. Then we have 1/3 to the power of 1, which would be 1/3. So we're going to go to the right 1 and up 1/3. And then we have 1/3 to the power of 2, which would be what? 1/9. Or if you put it in the calculator, you'd get 0.111. Same with 1/3. If you put it in the calculator, you'd get 0.333. So if you're not sure, if you're uncertain, just throw it in the calculator. So we go to the right 2 and up 1/9. Once we have our points, we can connect the dots. So our graph would look like this. Here, this would be an example of exponential decay because it's decreasing. On this page, you'll see this picture a few times on WebAssign. There's a few questions that give this to you. It is just a picture of like all the different type types of graphs, so it kind of just gives you an example of what each graph, depending on the base, would look like. So the question may say f of x is equal to 5 to the power of x. So you're going to use the one that has 5 to the power of x, which would be this line. So you use that to kind of get a gauge on what your graph is going to look like, and then you apply the transformations to it. So you'll see this picture on WebAssign a lot. You just look for the graph that it gives you the base for. All right, next. So here on the left side, is this graph exponential growth or decay? Growth, because it's increasing. So we have exponential growth whenever our base is greater than 1. So if we had something like 3 to the power of x, 2 to the power of x, 10 to the power of x, anything where our base is greater than 1 will have exponential growth. Now on the right, this is exponential decay because our graph is decreasing. So we'll have decay, our graph will be decreasing anytime our base is in between 0 and 1, meaning that it's a fraction. So a fraction less than 1. So 1/2 to the power of x would be decay. 3/4 to the power of x would be decay. Anything that's a fraction that's less than 1. What if we had 4/3? What about that? No, because this would be greater than 1. So that would actually be growth. So any fraction that is less than 1, you'll have decay. In example 3, it asks us to find the exponential function f of x is equal to a of x, whose graph is given. So I'm going to use this to help us. I'm going to say y is equal to a to the power of x. Our goal is to find a. X is always going to be our exponent. F of x is just the name of our function, so we're trying to find a. I just renamed f of x to be y to kind of help us a little bit. So in this graph on the left in A, it gives us a point. So do we know what x is? Look at our point. What's x? 2. So I'm going to plug that into x. So I have a to the power of 2. And what's our y? 25. So let's think about it. What number squared gives us 25? 5. So our function here would be f of x is equal to 5 to the power of x. So you just have to find a. So use the point to help you find a. So let's look at B. Before we start, is B exponential growth or decay? Decay. So what does that tell us that our base is going to be? Base is going to be a fraction less than 1. So let's do the same thing. We have y is equal to a to the power of x. Well, what's our x? 3. And what's our y? 1/8. So I have 1/8 is equal to a to the power of 3. Oops, 1/8. So you want to think, what number to the third power gives us 1/8? You can actually solve this mathematically, algebraically, and take the cubed root of both sides. What's the cubed root of 1? 1. What's the cubed root of 8? 2. So a would be 1/2. So I have f of x is equal to 1/2 to the power of x. And our base is a fraction. So that's just one way to kind of double check to make sure you're doing it right. One more thing on WebAssign, it's going to ask for the domain and range. So we're going to use this as an example and find the domain and range. So you want to use the graph to kind of help you find the domain and range. Let's put arrows on these because they go in both directions. So our domain is the x values Domain and range, we always start from smallest to largest. So we start with the smallest x value to our largest x value. Well, our graph is pointing forever in the left direction and forever in the right direction. So what would our domain be? Negative infinity to positive infinity. Perfect. Now our range is the y values. So we start at the bottom and go to the top. So what do you think our range is? So our graph is going to get really, really close to 0, but it never touches. So we would say parentheses 0. And then where does our graph go to? Infinity. So this is always going to be the domain and range for like your parent functions if our graph shifts in any direction. So if we shifted up 1, our range would then shift up 1 with it. So it would be from 1 to infinity. So it just depends on what transformations is happening to your graph. So use the graph to help you find the domain and range. So there are questions on WebAssign that ask for those. We're going to skip example 5. Don't worry about it. So 4.1 part 2. We're going to talk about compound interest. So compound interest is this formula here, where P is the principal, so that's the starting amount. R is the interest rate, but we're talking about the decimal version of the interest rate. So it'll give you an interest rate as like 50%. What's the decimal version of 50%? 0.5. Or it'll give you an interest rate of 4%. What's the decimal version of 4%? Just 0.04. You just move the decimal twice. So don't forget, the interest rate is the decimal version of it. N is the number of times interest is compounded per year. So that's the number of times each year. And then T is the number of years. So common values that we'll have for N, it depends on the wording of the question. It could say that it's compounded annually. How many times a year does annually happen? Once. So N would be 1. It could be semi-annually. That would be twice a year. Then we could have weekly. How many times a year would weekly be? 52. We have 52 weeks in a year. Could have monthly. N would be 12. We could have daily. 365. These I think are the most common ones. Oh, we could have quarterly. 4. Quarterly would be like once every quarter, which would be 4. Continuously is a different formula, which will be 4.2. So it has them all listed again on the next page. It doesn't list weekly here, but now we know weekly would be 52. So this question says, a sum of 1,000 is invested in an interest rate of 12% per year. Find the amounts in the account after 3 years if interest is compounded annually, semi-annually, quarterly, monthly, and daily. So let's start with annually. I'm going to start by writing our formula. We have A is equal to P times 1 plus R over N to the power of N times T. So we need to figure out what the P is, what R is, what N is, and what T is. Let's do one at a time. What's our P? What's our starting amount, the principal? 1,000. Garrett, what's the rate? Oh, no. Awesome. Our rate would be 12%, but it'd be 0.12 because we need the decimal. What's N? How many times per year is annually? 1. And how many years are we talking about? 3 years. So let's plug that all into our formula. So A is the amount that we're looking for. It's equal to 1,000 times 1 plus 0.12 over 1 times 1 to the power of 1 times 3. Calculator. You got to do these in the calculator. It's important to follow the order of operations. So that's where people get confused. The easy part is plugging it into the formula, knowing what goes where, but you do need to make sure you plug it in your calculator in the correct order. So I always like to do the exponent first because we kind of treat the math that's going on in the exponent as parentheses up top too. So I like to figure out what that is and just write it down. So 1 times 3 is 3. Now we're going to do inside the parentheses. So inside the parentheses, what would I do first? I have to do the division first. So 0.12 divided by 1 is still 0.12. Then we can add it, so it'll be 1.12. Then according to PEMDAS, we have to do our exponent next. So 1.12 to the third power would be 1.404928. You want to keep all your work in your calculator to make sure your answer is as exact as possible. So keep each step in your calculator. I'm writing it down to show you, but all of this can be done in the calculator. Just make sure you are organized and following the right steps, but keep it all in your calculator. So then I can just multiply this times 1,000. So we get 1,404.928. If I'm dealing with money, how many decimal places do I want? 2. So we have 1,404.93. Awesome. The 8 tells us that we have to round the 2 up to 3. So $1,404.93. Let's do quarterly next. So we need to find our P, R, N, and T. What's our P, our principal? 1,000. So we're using the same question, just now we are doing quarterly. What's our R? 12%, but what's that as a decimal? 0.12. What's the N? 4. Quarterly is 4 times a year. And what's T?
3.
We're talking about 3 years. So let's plug that into our formula. We have A is equal to 1,000 times 1 plus 0.12 over 4 to the power of 4 times 3. So some calculators, you could almost just throw all of this into the calculator. I would just say do it each in a step, but keep it in your calculator. So I'm going to do 4 times 3 first. So that would give us 12. Now I'm going to do the inside parentheses next. What do I have to do first inside the parentheses? I have to divide the fraction. So 0.12 divided by 4 would be 0.03. And then when we add 1, we get 1.03. What do we do next? Do the exponent. So 1.03 to the power of 12 would be 1.42576. It keeps going in the calculator. Just keep it in your calculator. Keep whatever number that is in your calculator and then just multiply that times 1,000. So we get 1,425.760. The 0 tells us that we round up or stay the same? Stay the same. So we're talking about $1,425.76. All right, let's do one more. Let's do daily. Yes. Yeah. So daily we need to know P, R, N, and T. What's our P? 1,000. What's our R? 0.12. What's N? 365. And what's T? 3. So let's plug it all in. We have A is equal to 1,000 times 1 plus 0.12 over 365 to the power of 365 times 3. I like to do the exponent first and just write that down. So we have 365 times 3 would be 1,095. Now I'm going to do inside the parentheses. So 0.12 divided by 365 plus 1 would be 1.000328. It keeps going, but I'm just going to leave it in my calculator. So now I'm going to take this answer and raise it to the power of 1,095. So we should get 1.43324. Keep it in your calculator and do the last step. Multiply it by 1,000. So you get 1,433.244. The 4 tells me that I round up or stay the same? Stay the same. So $1,433.24. One more thing about the homework. A lot of these can be done in your calculator. So I just want to see like this part, the equation. When you show your work, show me what you're plugging into the calculator. I want to see your equation filled in. From there, whatever work you need to show to get the right answer, that's whatever you need to do. I know a lot of you can just throw it all in your calculator, but I definitely need to just see this step. Also with the homework, some of the questions want exact answers. So for like the stuff that we were doing yesterday with the exponents, some questions want exact answers, some want decimal. I think it'll specify and say like round to the nearest 3 decimal places or 4 decimal places if it wants decimal answers. So you could always try the decimal. If that doesn't work, do the fraction. When we have negative exponents, so let's say I have 6 to the power of -2. What does a negative exponent do to my number? Makes it a fraction. So this would be 1 over 6 to the power of 2. And what's 6 squared? 36. So some of the ones that want exact answers, you just have to work out mathematically. Some calculators will do this and give you exact answers. If you have questions about your calculator, now would be the perfect time to ask while you're working on your web assignment.